Somewhere out there, right now, a star far older than our sun is still burning. If it has a civilization orbiting it, even one that's only a few million years ahead of us, that civilization should have already reached us. It hasn't. Nobody has. And the silence is not nothing. The silence is the mystery. In 1950, at a research lab in New Mexico, a physicist named Enrico Fermi was having a casual lunch conversation about flying saucers. And in the middle of it, he asked a simple question. If the universe is so vast and so old and so full of stars like ours, where is everybody? It sounds like a joke. It isn't. The numbers make it a real problem. Our galaxy alone has somewhere around 200 billion stars. It's about 13.6 billion years old. Our sun is less than 5 billion years old, which means there are stars out there twice its age, 3 times its age, quietly burning since before our entire solar system existed. If even one of those older systems produced a civilization, and that civilization built machines that could travel between stars, even slowly, even at a tiny fraction of the speed of light, the math says they could have spread across the entire galaxy in a few million years. A few million years sounds long. On a 13 billion year timeline, it's nothing. It's a rounding error. It's an eye blink. So if intelligent life is even moderately common, the galaxy should already be full. We should be surrounded. We should have been visited, signaled, noticed, colonized, something. Instead, nothing. Not one confirmed signal, not one probe, not one piece of hard evidence anywhere, ever. Just a silence so complete that scientists gave it a name, the Great Silence. Here's what makes it worse. This isn't a case of us not looking. We've pointed radio telescopes at the sky for over 60 years. We've scanned millions of stars for the kind of signal a civilization might accidentally leak into space the way we do. We've looked for megastructures built around stars to harvest their energy. We've looked for the chemical fingerprints of industry in the atmospheres of other worlds. Every single search has come back empty. And it's not that intelligent life should be rare. By most estimates, there are billions of Earth-like planets in the habitable zone of their stars in our galaxy alone. Billions of chances, billions of years for something to go right. So either we are, against all odds, the very first civilization in a galaxy 13 billion years old to look up and ask this question, or something else is going on. Something that stops civilizations from getting loud enough or lasting long enough for us to notice them. That's the part that keeps astrobiologists up at night. Not the silence itself, what the silence might be evidence of. One answer is called the Great Filter. The idea is simple, and it is not comforting. Somewhere on the path from dead matter to a civilization capable of reaching other stars, there's a step that's almost impossible to pass. A filter. Something that kills off almost everyone who tries to get through. And here's the part that should actually bother you. We don't know if we've already passed our filter, or if it's still ahead of us. If it's behind us, if the impossible step was something like the origin of life itself, or the jump from simple cells to complex ones, then we got lucky. We're rare. We're one of the few who made it through, and the silence makes sense, because almost nobody else does. But if the filter is ahead of us, if it's something like what happens when a species invents nuclear weapons, or builds an artificial intelligence it can't control, or simply grows too fast for its own planet to survive it, then the silence isn't proof we're alone. It's proof of what's waiting for us next. There's a second answer, darker still, and it doesn't require anyone to have gone extinct at all. It's called the dark forest hypothesis. And the idea is this: maybe the universe isn't empty. Maybe it's full. Maybe it's silent for the same reason a forest at night is silent. Not because nothing lives there, but because everything that lives there has learned that making noise gets you killed. In this version, every civilization that reaches the stars eventually realizes the same cold truth. You cannot know if a signal you receive comes from something friendly or something that sees you as a threat or a resource or simply an inconvenience. And you cannot take that risk. So you stay quiet. You listen. You never transmit first. And if every civilization reaches that same conclusion independently at roughly the same point in its development, then the silence isn't the absence of life. It's the sound of everyone else already knowing something we don't. Right now, we're one of the loudest things in this section of the galaxy. We've been broadcasting radio and television signals into space for over a century. We've sent physical, golden records into interstellar space, with our location marked on them, on the Voyager probes drifting further from home every single day. We did all of that before we had an answer to Fermi's question. We did it assuming the silence meant nobody was listening. We still don't know if that's true. We don't know if we're early. We don't know if we're rare. We don't know if we're being watched or measured or simply haven't been noticed yet, the way a single firefly in a dark field might go unnoticed by everything larger moving around it. That not knowing is the whole shape of the problem. It's why this question, asked over a casual lunch more than 70 years ago, still doesn't have an answer. So here's the one thing worth sitting with. The silence out there isn't empty. It's a question mark, stretched across 200 billion stars. And whether the answer turns out to be that we're rare, or early, or being watched, or simply not yet found, the not knowing is the closest thing we have to a warning. Look up tonight. The stars aren't just distant, they're quiet, and we still don't know why.